Good evening, everyone. So today we are going to learn the application of the Laplace transform in the circuit theory, right? So before that, we'll discuss the transform of impedance. So first is the resistance. In the circuit, you have a resistance. The voltage across resistance is the Vt and current is the It. So transform will be because the time domain relation is the Vt is equal to Rit. When you take the Laplace transform of both sides, V of S is equal to R is the constant, I of S, right? So it will be simply, so it is simply R plus Vs and Is. Now come to the inductor. Vt then It. Let's say let's assume that it has some initial current I0 minus. From dynamic equations we know that Vt is equal to L di upon dt. Take the Laplace transform of both the side. Vs is equal to L, and you know the differentiation Laplace transform of the differentiation of the functions, that is S Is then minus I0 minus, right? So it is the Ls Is minus L I0 minus. So you can see that the polarity, this is the voltage transform of initial voltage transform of initial current through the inductors. So equivalently you can write a box which is Ls, then you see the polarity, right, is the Li0 minus, and this is your Vs and this is your Is. See the direction of the current initial current. So this current directions will be same if the voltage is the positive here, negative, and the current will be flowing from the positive terminal to negative terminal. So this is the aid to remember, right? You can also put the equivalent current source using there is source conversion. This can be written like this: Ls, and the current will be this. That is I0 minus upon S. That is 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 equal to Vs upon Ls and plus I0 minus upon S. Okay. Now come to the third case, that is the capacitors. Let some initial voltage V0 minus. You know the basic equation, that is IT is equal to C dVt upon dt. Taking the Laplace transform of the both the side, Is is equal to C S Vs minus V0 minus, that is Cs Vs minus C V0 minus. So this is the initial current, that is the current transform of the initial voltage across the capacitors. So you can write like this: a box which has 1 upon Cs, then a current in which directions? Opposite directions. C V0 minus. This is your V S and this is the Is. You can easily by using a node equation, you can easily write the Is is equal to Vs upon 1 upon Cs, that is Cs Vs, then minus C V0 minus. Also you can write Vs is equal to 1 upon Cs into Is plus V0 minus upon S. V0 minus upon S. So you can represent like this: 1 upon Cs and a voltage source with same polarity but transform is different. It is plus Vs and this is your Is. So you can see that this is the voltage transform of initial voltage V0 minus. Voltage transform of initial voltage V0 minus. So the transform of the capacitance, so capacitors is transformed to, so in summary you can say the when there is no initial voltage, okay, or initial current, LAR is transformed to same R, L is transformed to Ls and C is transformed to 1 upon Cs. Okay, let us apply the transform. How we are going to apply the this Laplace transform, or you can say impedance transform, to a given circuit. Suppose you have been given a circuit. This is your 10 volt. One by 4 farad. Initially the switch was at the position A, right? Initially switch was at position A at t equal to 0. It is close to B. So you need to find the initial value. So initial value Vc. Okay, we need to find this Vc, Vct for t greater or equal to 0. So initially the was at the position A at t equal to 0, it is moved to position B. Then you need to find Vct for all value of t. So what you will do? You will before moving the switch, you need to find all the initial value. Here only one capacitor. So as you know that when the switch was at position A, the capacitor would have been fully charged to 10 volt. So Vc 0 minus is equal to 10 volt. Now the circuit becomes like this: a capacitors. This is R, which is 2 ohm. This is 1 upon 4 farad, and for t greater than equal to 0, and this is a some voltage, that is Vc. This polarity Vc 0 minus is equal to Vct. Vc 0 minus is equal to 10 volt. So apply the transform. So Laplace transform, apply LT for the for above circuit. So this is becomes 2, and these capacitors become this with initial voltage with polarity shown. So this is 1 upon Cs, that is 1 upon 4s, that is 4 upon s, that is 4 upon s. Then a voltage source of polarity as shown, that is that voltage source transform of the initial voltage, that is just now we have covered, that is V0 upon S, V0 minus upon S. V0 minus is the 10, so 10 upon S. See how it is easy. Now we required this VCS. So VCS potential division, you see VCS the same voltage drop across the 2 ohm resistors. So potential division, so 2 upon 4 upon S, this is the impedance, this is the impedance transformed impedance, and this is the voltage source type impedance transform of the initial voltage. So plus 2, right, into 10 by S. So take out the 2 common and cancel out, and you have S upon S plus 2 into 10 by S. S cancel, so remains is the S plus 2. You know it is very simple one, and by referring the Laplace transform lookup table, you have Vct is equal to 10 e raised to the power minus 2t ut, right? That means for t greater or equal to 0, multiplication of ut to a function shows that for t greater or equal to 0. Very easy. Simply manipulation of the algebraic transform. Algebraic, if you know the Laplace transform way, you see the, we do have any circuit, nothing, just a algebraic manipulation of the circuits. Okay. Another way is to write the differential equation or solve it in time domain, or write the differential equation and use the Laplace transform, use the Laplace transform of that differential equation, then solve it. All are simple questions. So okay, I'll discuss the one question actually, which is of relevant. All the questions are relevant. You can find in the PYQs. Suppose you have the circuit like this. You have been given 1 kilo ohm, 0.1 microfarad, this is your V0t, and you have been applied a VIT input, but they have given that VIT is like this. Find the V0t. Find the V0t. So I told you VIT is equal to waveform synthesis, VIT is equal to 3 3 UT क्या हो रहा है VI minus 3 U T minus 2. If you can find the, because the your circuit is LTI time invariant, so you can easily find the for output for the UT, output for the UT minus 2, then add together. So here I will use the relation we have studied, that is V0t is equal to V0 infinite minus V0 infinite minus V0 0 plus e raised to the power minus t upon tau. Here tau is the RC, R is equal to 10 to the power 3 and C is equal to 10 to the power minus 7, which is 10 to the power minus 4. V0 infinity, V0 infinity, I am assuming first 3 of UT, that means 3 volt. So if the input is kept at 3 volt, so V0 infinity will be the, because capacitors will be fully charged and V0 infinity will be 0, and V0 0 plus, whenever you apply this 3 volt, so capacitor will act as a short because there is no initial charge, so all of the voltage will appear 1 kilo resistors, which is 3 volt. Now apply for input 3 UT, your output is V0t is equal to 0 minus 0 minus 3 e raised to the power minus t upon 10 to the power minus 4. That is that is your 3 e raised to the power minus 10 to the power 4 t. But when you shifted it e 3 ut minus 2, as it is time invariant, your v0, this output will be the 3 e raised to the power minus 10 to the power 4 t minus 2. Then the input is 3 ut minus 3 ut minus 2. So using the property of linearity for input, vit as shown in the graph here, okay, as shown in the graph here. So output will be the 3, so v0t will be the 3 into, because all the term, e to the power minus 10 to the power 4t minus, so it is for the t greater or equal to 0, 3 power ut and ut minus 2. So this is your ut minus e to the power minus 10 to the power 4 t minus 2 ut minus 2. This is the solution. That means the solution will be looking like this. Okay. So this will be solution at this point, and this will be output waveform looks like. Because time constant is very small, okay, so decaying will be very less. It will be almost looks like, okay, the decaying will be very less. Now we'll discuss the last part of this topics is the your second order system. How will you analyze the transient analysis of second order system? There are two methods you can use, okay, whether Laplace transform method or time domain method. Laplace transform method, same way you have to transform all the element, then solve with the network analysis, then you find the an algebraic equation, then do the partial fractions, then you look up for the your Laplace transform table and get the result. But many times you will find that time domain approach will be very helpful. So let us start. Okay, just look at the ways I am doing. Okay, you have been given a second order system which is like this. and a current source of 4 ampere, and here is a switch. Okay, and it is closed at t equal to 0. And the value is a 0.5 farad, right? And here is the 1 upon 3 Henry, and this is your 0.4 ohm, the IR. The initial value of that is IL0 minus given. The question says that you have been given initial values. IL0 minus has been given 2 ampere, and VC, this is your VC polarity also. VC0 minus has been given as the 6 volt, right? The switch is closed at t equal to 0. Find the expression of IRT. Any expression you can find out, but we need to find here expression of IRT. Okay. So first of all, initial value we need to find. Initial value of IR and the initial value of, because we are interested in the IR, so initial value of DIR upon DT. Why? Because we need to use it. Okay, so draw the T0 plus circuit, that is after closing. 4 ampere, 0.4 ohm, inductor initial current, so it will act as a current source of 2 ampere, and capacitor will act as a voltage source of 6 volt. This is the initial circuit for t equal to 0 plus, right? So this is your R, this is your IR. Can anyone say what is the IR 0 plus? You can see 6 volt is exactly acting across the 0.4 ohm resistors. So IR 0 plus is equal to 6 upon 0.4, 60 upon 4, that is your 15 amps, right? And you can see this is your VC capacitor, so you can say that IRT is equal to dVCT upon dt. Sorry, oh, VC upon R na, VCT upon R, VCT upon R, because this is your VCT upon R for general case. I mean for general case, right? And DIR upon dt, DIRT upon dt is the 1 upon R dVCT upon dt. That means DIR 0 plus is equal to dt is equal to 1 upon R dVC 0 plus upon the dt. That means we need to find the dVC 0 plus at dt, right? But how to find the dVCT upon dt? Because we know that IC IC 0 plus, sorry, yeah, correct, ICT is equal to C dVCT upon dt, right? So dVC 0 plus upon dt is equal to IC 0 plus upon C. What is the IC 0 plus? This is the IC. So this is the 4 amp coming, and IR we just find out the 15 amperes. Yes or no? IR is equal to 15 ampere. That means how much current here coming? This is the 4 ampere is coming here, going to 15 ampere. That is 11 ampere here. In this direction 11 ampere. In this direction 11 ampere. Here the 2 ampere. That is here is the IC is the IC 0 plus, or IC 0 plus is equal to minus, because see the direction here, minus, that is 11 plus 2, that is a 13 ampere, right? So dVCT 0 plus is the, so dVC 0 plus upon dt is equal to minus 13 upon C. C is given as a 0.5, right? See here 0.5, that is minus 26 volt per second. So use this relation to find the, so dir upon dt 0 plus will be the minus 26 upon r. R was your 0.4. So minus 260 upon 4, which is minus 65 ampere per second values. Now come to the characteristic equations. So the characteristic equation, when you make the circuit source free, when you make the circuit source free, when after connecting you make the source free, that means reduce the current source to 0. So it is a simply parallel circuit of R, L and C. R, L, C, and you know the characteristic equation of this, that is S square plus 1 upon RCS plus 1 upon LC equal to 0. Put the values, S square plus 1 upon RC, R is the 0.4, C is the 0.5, right? 0.4 and 0.5, and 1 upon LC, 1 upon 0.5, and L is your 1 upon 3. L is 1 upon 3 equal to 0. Square plus, you see here, that is 100 upon 20. 100 upon 20, that is 5s, plus 30 upon 5, that is 6 equal to 0. So S plus 2 and S plus 3 equal to 0. That means S1 equal to minus 2, S2 equal to minus 3. So IR we need to find IR. So complementary functions will be the solution will be complementary functions, and particular integral. So complementary function will be the c1 e raised to the power minus 2t plus c2 e to the power minus 3t. That is for t greater or equal to 0. Now next part is this is the equation 1. Next part is the forced response or particular integral. Forced response is same as the particular integral in a differential equation, pi. So can anyone guess the forced response from this circuit? Understand forced response? This is the steady state response after long time. This is the steady state response after long time. That means when you close the switch for long time, what will be the value of IR? So when you close the switch for long time, like t tends to infinity, this inductor will act as a short, capacitors will act as a open. That means no current through the capacitors, all the current, because short, all the current through the inductor. So no current flow through the resistor. So you got forced response or particular integral is 0. So total response becomes this and this. So c1 e raised to the power minus 2t plus c2 e to the power minus 3t, and put the initial value for 0, IR 0 plus how much was the IR 0 plus, that is 15 ampere. That is equal to 15 is equal to C1 plus C2. This is your equation 1, right? Then differentiate this equation, dir upon dt, that is dir t upon dt is equal to minus 2c1 e raised to the power minus 2t, then minus 3c2 e raised to minus 3t. So evaluate at t equal to 0 plus, and we have found it minus 65. Minus 65 is equal to minus tc1 2c1 minus 3c2, which gives you the 2c1 plus 3c2 is equal to 65, equation 2. So now you can understood why we have to calculate the first derivative, because we need two initial conditions for the second order system. We need three initial conditions for third order systems. That means initial value of the variable, first derivative, initial value of the first derivative of variable, and initial value of second derivative if the system is third order. Here the system or the circuit is second order. We need IR 0 plus and dir upon dt 0 plus. Now you solve it. I multiply 2c1 here in the equation 1. Equation 1 into 2. 2c1 plus 2c2 is equal to 30. So subtract it. That is c2 is equal to 65 minus 30. That is 35. And c1 will be the simply 15 minus 35, which is minus 20. Now your IRT is equal to c1, that is minus 20 e to the power minus 2t plus 35 e raised to the power minus 3t, and ut stands for, as always I emphasize that, for t greater or equal to 0. This is the complete solution of the second. So this way you can do any sort of given second order system or third order system in same way. So I'll give this assignment to you, that you should find the applying same equation you should find by applying the Laplace transform method. Okay, you just write I have done in the time domain, and you compare which one is getting the more time. Okay, just to please go through all the topics, that is of all the part of transient analysis, so that you will be able to understood completely the transient part. Don't think that if you it is difficult and you will leave the transient part, because if you leave the transient part, then your dream of the pursuing a career in electronics will be also gone, because everywhere you will find the transient analysis, right? In digital design, digital circuit, digital analysis, mixed signals. Okay, so better to learn the transient analysis. There are 5 parts for the transient analysis. Okay, in next class we'll discuss the some questions appeared in the previous year GATE papers. See you in the next class. Till then, take care. Good night.